Welcome back and welcome to lesson 6 in the Houdini Environment Beginner Series. We're going to continue where we left off and keep going with some procedural modeling, and this time setting up our tower here. So this is the network we've got for our tower, and it looks a little bit more complicated than the last one, but the same principles are applied, and there's just a few extra things going on that help us set up different ways to do these, and then also let us create essentially this building rather than the other pieces, obviously. So the general workflow that we have here is we create an input shape, and I'm going to rearrange this so I can walk you through this network first before we go node by node. So this again is our same scene here, exactly same scene, but I just have this lesson slide that I'm going to slide through while explaining the nodes on this side here. So our general workflow is we choose an input shape. In this case, I've chosen to do a circle, which is randomly scaled and randomized divisions by this random function, which we've covered before, so I'm not going to go over it again. If I click play, I get a random amount of 5, looks like 5. Let me change this to 7 just for fun. So now 3 to 7 random points are scaled and scattered, not scattered. This circle is created with 3 to 7 random points, and its uniform scale is randomized as well. And then here is just a quick sample. There's other ways we can do it. So in this case, I took a circle, which was just, I made it bigger with a few points. I did a group range. So in the same way we can do a group and create a point group based on certain rules, like normals or bounding regions, we could disable this and create a bounding box. If I select this group node and hit enter, I can then create a box that creates a volume here, in which case I have to set it to points to collect those, but it groups these orange points now that are within this box. So there's lots of different ways to group. And a node that side effects has put together for us is a group by range, which lets us group usually with repeatable patterns in effective ways. So here I did 1 of every 3. You can do 1 of every 2, 1 of every 1, and I'm grouping points. I then scale this group, which I should probably rename to something new, my points. You can keep the default group names if you want, but I like to name them something that makes a little more sense, just so if they're showing up on my spreadsheet here, I kind of have an idea of what's going on. And this case is the input I've chosen, and I also set up a separate one where it looks like it is a box with a lot of points. So essentially, I'll walk you through here, and then I'll show you the reason I did these 3 things here. So we pick a main shape, and then that main shape will have a center, a centroid, which we'll compute later, find the center and find the center. And then within those 2 shapes, we'll do 2 things. We'll split this to the left, the center, and we'll find the centroid of this shape, and we'll create essentially our tower. So I'm going to go down here, I'm going to template this flag to see the results of what this network does. And we'll give it a minute to think. All right, now the reason it's different is because this switch here is coming in on this one. This switch is set to 1, so I'll leave it at this one and then show you guys actually. So template this down here, and there we go. Now you can see what's going on. So what happens is it takes our input shape, it splits it here, which is what's done sort of here, but we'll get to that later. On the left side, we're creating a tower center, and we're doing that by stacking cylinders on top of each other. Okay, it looks like I've got this organized in the wrong way. The tower center is on the right, and we're stacking the cylinders on top of each other. And then the poles are on the left. So when I made these slides, I got the order mixed up. But this one creates the tower center. And if I flip this to have that visible and then this templated, which it is, that'll be a little bit easier to see. So this right one creates the tower center, and it does that by finding the center, placing a cube or a cylinder, excuse me, and then repeating that process a few times. So I place a big one, then randomize, place a different one, then randomize, place a different one, then randomize and place a different one, which is essentially what's done here. There's also a few settings that are done to randomize which pieces here are being extruded, what the size of these shapes, the heights of these are, and those are all done with the random expression, which I set here, and we'll see that when we go node by node. But in general, I'm taking this point, stacking things on top, and then creating this, which is our tower. Very tall in this case. On the other side, I take the points, and I'm doing a few things, but mostly I'm creating a single tower here, and then I'm copying this to those points, which is the same way we set up the grass. We created normals and we copied, space G, I'm going to reframe, these points to our object. And now the reason I have this switch here is because each different input, because we set it up procedurally, lets us change the shape. So if we wanted a big tower system, we could do that. We can continue, down our network. And you see now this side is the wires. So we take the centroids of our tower, which we'll get to later, and we merge it with these points, and now we're going to find where those points are at the top of this tower. And then what we do is we do a few things, but essentially we're going to add and create a line in between each of these points. We're going to resample that line in the same way we resampled it for the grass. And we're going to droop, so we're going to lower the line, and we're going to do that by adding a Y position based on the curve view. So exact same workflow that we did for the grass blades. And then a few other things, but we're going to randomize. We're going to use an attribute VOP to distort. So in the same way for the grass that we distorted the base and the top of the grass. And then we're going to use our wrangle here to say, okay, keep the distortion only on the middle parts here. So we can control where on our curve, where on this wire curve, our noise is being applied. And then that does that for every wire. And you can see, you can get some crazy detail really easily, and it's all set up based on this input. So now I can get this shape, and even this shape. And if I really, really wanted to go crazy, I could do a lot of wires, and I could make it really big. I could even do many, many wires. So let's see. I do not recommend doing this because if you go too high, you might freeze your computer. But you can see really how far we can push this. And if I merge it down to the bottom, there you go. Now we've got a massive tower, which is a little too much, way too much actually. And the reason this center tower is so tall is because what I do here is I measure the size of the area. It looks like I do that here. And then I scale our top of the tower based on the area. So if I hit here and hit space G, you can see the tower is really tall because the area, the base shape that I've used is really big. Probably it's too tall, but we're going to go back to our basic example. I'm going to space G to frame it, and then you'll see. Now, once we merge all those together, and we'll still go through node by node, so don't worry about that. I'm going to disable this so I don't see those points anymore. We clean, we remove some attributes we don't need. We remove, looks like a few more attributes. This one, I guess I did groups, and then this one I did the attributes. And you can see actually this tower, this underscore tower, I've created these attributes here for groups that I use for shading. So I wanted certain parts of this tower. I'm going to color this actually. Well, it's a little too dark. I'll do this color. I wanted certain parts of this tower to have certain materials and groups. So then when I'm shading this in Stage in Solaris, I can say, all right, for this ridged metal, I want this to be a certain kind of metal. For this stone, maybe I want this to be the concrete. For these wires, maybe I want them to be rubber. So that lets me group them out. And then I added this underscore as the group name. So then when I clean out my attributes, I can say, hey, delete every group unless it starts with underscore tower. And you can see if I middle mouse button, we have a few other groups, but we only want to keep the underscore tower groups. So that's what this node does. And then next, we do a few operations, but we split these out again, sort of like how we did with the box. In this case, we just add a group here, which is going to be for shading. And then I name it for our objects. So for when we import these into stage, the name is respected, and we've learned that before. So we're going to keep leveraging that to our advantage. We got this name again. And in this case, we're just beveling it to add some more resolution. I'm going to hit escape to hide those. Adding normal, UV unwrapping, transforming to scale. And that's the same process pretty much for all of these. And I did them separately so I can keep them separate, and then I can also name them separately. And then what I can also do is adjust the UVs individually for these parts. And then for the concrete, actually the area, what we want to do is we want to combine these all together and then get smooth transitions between these. And we want to remesh this so they're all connected as one whole piece. And the way we can do that is with volumes. So I bevel it, I subdivide it, and we'll go through this later. And then I do a VDB from polygons. Which creates a surface VDB, an SDF, which is the type of VDB it is. And then I set our resolution size, or voxel size, to be small enough here to where I get the resolution that I want. I smooth it, and then I convert it back into polygons. So now you see its actual points again. And here it was points, but the topology wasn't all blended together. It wasn't as smooth and uniform as I wanted it to be. So adding this VDB remesh step let me combine all these pieces into one, and then also get a nice even topology. And then I UV unwrap it, scale the UVs again, and they're not perfect, but for the use case of this small environment, these are fine because they're also organic and very repeatable, textures. And then this is a shade mask, which I created for ambient occlusion, which I will show you here, and we'll go through next time when we're actually setting this up. We do this on the house as well. It is a mask by feature. And then the mask we're actually creating is ambient occlusion. And then that saves it by default to mask. So if I did a color here, whoops, if I can connect these two, and if I set ramp from attribute and I set it to mask, that'll create this attribute here. So I didn't want it in a vector, I wanted it as an occlusion. And the way it was already set up was by using masked by ambient occlusion, which is the same node, but it looks like it's already set up to calculate the ambient occlusion only. And then I just play with these settings until I liked it. So you can mess with that. These are the settings I actually used. When we go back to this node by node, I might reset these, but it was really just trial and error, and then messing it with certain ones, seeing what it looks like. And then the bias, maybe we change some things. And then you can hover over each of these individual ones to see what it does, or you could look this node up in the documentation by pressing this little question mark. If we let it load. And there we go. So you can do that with all these nodes, but we're going to continue for now. And then we merge those together. We do the rest attribute as well. So that's for our shading. When we combine them with noises, we want to have some material have a certain color, maybe do darker areas on certain parts of the noise, or blend two materials. And then we did a time shift because we're still here in a procedural thing based on the frame number. So I selected up here because the volumes here take a little bit of time to cook. And then I do a time shift, I save, and then I actually set a tower number, which is an extra attribute I made. And the reason I did this was later in actually the lesson, in lesson 20, we're going to import these all into stage, and then we're going to reference them back from stage, from Solaris, into the, you can see I arranged them here. We're going to import these all, and we want to reference them back, and then we want to know which part of which tower belonged to which setup. So for this center pole, we want to know, was it tower 2, tower 1, tower 3? And that's how I've chosen to set that up here. So essentially what I'll be doing later is connecting wires in between these, and that's one of the challenge exercises that we'll end the series with. And then I will probably do a few of those as bonus lessons. So follow and be sure to hopefully try to complete those yourself. But awesome, that's a quick overview of what it is. And now I'm going to pause, reset, and then we'll come back node by node, and I'll walk you through exactly what these things do, and I'll showcase a few other changes we can make to kind of actually understand exactly what's going on. All right, welcome back. We're going to keep going, and we're going to go node by node, and we will go starting with this right side, and then we're going to look at the left side, which are the smaller towers, and then we'll look at the cables in between, and then we'll look at the setup for our groups again, and then we'll review and refresh a little bit at the end. So to start, make a little bit more space. This again is our input geometry, and we saw that we can switch this and it automatically follows through the rest of the network based on the input geometry. So for now, we're going to stick with circle because we now have enough variation with these frames to see if we wanted to see what it looks like with 4 towers or 5 or 7. We can just switch the frames and get a different input. We measure the area with a measure node, which creates a primitive attribute area. We use this later actually to scale the height of the tower based on the size of, well, the area of our primitive. We extract the centroid to get the center point of that object, which is done with an extract centroid node set to detail, which takes everything incoming here and it gives you 1 point at the center, or the centroid. Firstly, to do the center spoke, we'll do this, and then I'm actually recolor each of these boxes so we stay a little organized. But we get the centroid. Again, we read the area primitive, or the area value, which you can see is transferred actually. That's a good thing to note. So this area attribute is created by default on the primitives right here. And when we create our centroid, we want to transfer this attribute area from primitives here to points. And we'll need that so when we access here, you can see the area in this bottom spreadsheet. We transform this point up by the spreadsheet, we merge, and then we add. And we have a different add this time because there's only 2 points, so we're able to add just by all groups. But when we were doing the grass lesson, we wanted to make sure that, so see polygons by group, and it'll automatically add those together. And by add, I mean connect the line. But we wanted to do the grass by individual points, but since there's only 1 point at the bottom and 1 point at the top, obviously with only 2 points, there's only one connection that can be made. We orient along the curve, which is used to actually sweep the geometry. We don't technically need this in this case, but when you're sweeping in curved geometry, or if it was a distorted line, you would in general want to have this attribute, which creates an up attribute and then an N, a tangent normal attribute, which is helpful for working with curves. So if you are sweeping something that's displaced, you might get a weird result if you do not have these attributes needed. And then I resample. So I want a lot of detail because later when I sweep, I'm going to use this scale by ramp to change the thickness of this actual line. And the way I did that was a sweep node. And we learned in the graphs lesson that you can manually do this with attributes and wrangles. But I want to set it to round tube. And we can just do a scale. So I'll add some random shapes, select them all, and I'm going to change the interpolation to linear. No, constant. That's what it was. I was looking for step, but it is constant. And now this will give us that step in between with an instant transition between the values. So I just did that to create my little shape. Looks like it was a little bit smaller what I actually made. And then I matched size to place it right here and then normal. So it looks what I did. Looks like what I did. Let me see. Whoops, match size. I took this match size node and I set the min to the max, which was scaling it now to be at 1 for the target size. This technically, I guess I wanted it to be a little taller. You don't necessarily need this. So if I look later at the tower, this really just moves it up 1 unit. I must have been doing some kind of development when I had something else in here to match, but in this case, it just essentially matches the size and then pushes the base of this wire, so this incoming geo, to the top of the bounding box set by 1. And then normals I add as a good practice, and then I group it, which is the tower base metal that I later use to split up into here for shading and for UVs. All right, I'm going to color this as a lighter. Actually, I'll do a dark. I'll do a black, saying that we've already covered it. All right, so that is the center spoke. For the other parts of the area, same idea. I took the centroid and I now took a tube and I wanted to place that tube at the centroid. And this I could have done manually, but I was under the impression that this might not always be at the world origin. So if I did a transform, and this is one thing where your edge cases, you have to kind of plan ahead. And sometimes with procedural modeling, you're making the assumption that everything's at the origin. But if we're not at the origin, you see, there we go. It looks like in this case, I did not make that assumption that would be at the origin, but in this case, I did. So that's something to note. And some things such as this would break your procedural setup. So it does sort of break it, but not entirely. But that's one thing to know. So depending on what you need, you should be aware of different edge cases. Like, would it be at the origin? Would it be at 200? Will it always be at 0? Will it be upside down? Maybe even, for whatever your input geometry is. So I take our tube, excuse me, and it looks like I randomize the scale here, bigger and smaller, and then I place it with the match size, min to max. And then I do it again, and then I merge it back. And then again, and then I merge it back. And on each of these tubes, it's a little bit different of a height that I manually set, and then it's a little bit different of a scale that I set with our functions here. And it looks like actually there's one more random thing I added here, which was a seed. So the way I did this was I took our transform, which is a fresh transform, and I said fit 0, 1. So I want a random value, and I want to use a random function, where I want to fit a random value between 0 and 1, and I want to seed it based on frame times, I'll do 12, and I want to fit that from 2 to 5, or 2 to 4. And there we go. But now, say we wanted to change this to 25 or 52. We could either click here and manually change that, or we can do another expression. Actually, we can't do that here, so I will show you how to do that. This is similar to the tutorials for the materials, but what we're going to need to do is we're going to hit edit parameter interface, which lets us change the variables here. And if you followed along with the material lesson, this should be more than familiar. We're going to create a integer. Actually, we'll create a folder. We'll make it simple for new settings. Again, this is all done in materials. So if you want an introduction to how these can be done, I'd recommend checking that one out. I'm going to drag an integer here and I'll set this as our seed. And now we'll say name will be seed. And now what we want to do, I'm going to exit this out. We want to get this value somehow into here. So what we're going to do is we're going to right click, copy parameter, select where we want to paste it, and we're going to right click, paste relative references. And now we're saying reference the channel seed and multiply it into our function. So now we can drag and drop, or we can drag and slide and change our seed. And if we wanted it to go from 0 to 10, we can do our seed here. And on range, we could say 0 to maybe 1,000 and apply and accept. And there we go. Now we can drag and easily change seeds for our procedural modeling. So it looks like I did this because when I was creating these, I just alt dragged and I wanted to quickly change seeds without having to click, type. I just use this one. So again, take the tubes, randomize the size, match them, merge them. Tube, match, randomize the size, match and merge. And then all the way down here, and this chain here just continues to go. And that's really all it is. And then for this other side, what I do use is I do break out a few of these because I want to create these rings that go around the center, and I want to randomize these and I want to make them metal. So instead of the concrete, I want these to actually be a different material. So what I did was I picked a few of these tubes where I liked the placement. So I'm going to ghost this one with this template flag. So I was like, all right, I kind of like this idea, this flag, or excuse me, this cylinder here. So let me save that out, make it a little bit bigger so it won't intersect our concrete. And then it looks like that's all I did for this one. So then down here, I was like, all right, I like this one too. Again, make it a little bit bigger. I subdivided it again with this subdivision that does not smooth the edges, it just adds the loop cuts. And then I grouped with a keep by normals, direction of 1 and a spread angle of 1. So I only keep what's up. And then the group node has a nice functionality where you can include normals in the opposite direction. So with one node, I can group the top and the bottom. I deleted those because I didn't want them. And then I pushed them out a little bit more by using first a group by range. So this one we did for the first time actually up here, this group by range. But what I said, I want to group random points from 1 to a random number. So either every 1 of 2, 1 of 8, and 1 of 6, 1 of 5, and I want to randomize that on every frame. And then what I want to do is I want to peak, or not peak, I want to blast those and extrude those. So I do want to do a similar thing to peak, but not exactly. But I named it peak. I can name this peak my faces. And you see, I renamed it to peak my faces, and I'm trying to delete that, but that doesn't exist because when I set the group, it's named peak. And the reason I changed the names of the groups is to show you that the names are not intrinsically recognized by Houdini. So you can change them to whatever you want. And some names are, like P-scale and N and V. Those are important to Houdini. But some cases, such as here, you don't actually need certain names. You can kind of do whatever names you want. It's just keeping the names consistent between these two nodes is what's important. So I extrude. What I could actually do, and why not? Because we're learning together. I could do an attribute randomize. And what I'm trying to do, and I'll tell you before I do it, is I want to create the Z-scale attribute that we learned is here on our extrusion. and I want to randomize that for every one of these so they can be extruded a different amount. So I could do that with a wrangle. I could do that with multiple different ways, but I'm going to use an attribute randomize to create a z-scale, one float, or one vector, excuse me. So this is the x, the y, not x, y, z. This is a one-dimensional vector, so a float. This would be a two-dimensional vector, so like a UV coordinate. And this would be a three-dimensional, not vector, I'm misspeaking, so excuse that. This is a three-dimensional value. So it has a 0, a 1, and a 2 dimensions. You can have as many as you need. A float is 1, a UV coordinate would be 2, and then a vector would be a velocity, or a normal is typically a three-dimensional vector. So like the face, a 3D direction here, this is a three-dimensional vector. A velocity of a point traveling through space would be a three-dimensional vector. And then I extrude based on z-scale. And you see the reason it's not working yet is because this is set to points. But hey, I want to extrude on our primitives. And a way we can see that is by actually looking at our geometry spreadsheet. So I only want one dimension. And that's why the spreadsheet's so important, because you can actually debug what's going on. It's like, what's happening here? It's the z-scale, but really it needs to be on our primitives. So what we could do is set this to primitives, and then it'll work. Another thing we can do, and I'll show you this because I want you to learn, is do a attribute promote, which lets us take a value from one class here. By class, I mean either a point, a primitive, or a detail. And it lets us take the point attribute, z-scale, and let's put it on primitives. There we go. And if I make the randomization a little bit more extreme so we can see a little bit better, you can see this is randomizing the attribute and then promoting it to our primitives. And we can promote in multiple ways. So this would take the average of all of these points. They each get their own random p-scale, or z-scale, excuse me. And this is going to average those when it promotes it. Or I could say take the minimum or take the maximum. So also an important part in Houdini in general, and not just modeling, is being able to move attributes from points to primitives to details, and then back and forth, and then actually know what's going on and what you're using the attributes for. So this is kind of cool. And this again lets us just see what these different variations look like. And we can see that's not extruding, excuse me, as much as we would expect. So all these different things you can mess with, but that's how I chose to create them. I'm actually going to disable the z-scale now because I do like how they're all even, but you're welcome to work either way. And then I merge it down, and that is my tower. That's the rigged metal part of the tower, excuse me. And then this thing, what I'll do is I'll show you what it is, but I'll get to this later. I just take the top part here of our last cylinder we added, and I decided that this is where I wanted the wires to connect. So I needed to get this area, and I needed to use this into our other area of the network that actually creates the wires. So that's all this does. It says, all right, fetch this area, fetch this part of my tower, and then here we're actually going to later say I want to attach all these wires from these points, and I want to connect them to this point. And that's what this network does. Well, technically that's what up to here does. But we'll go through that when we get to that after this next section. All right, to continue, we are going to go back up to the next part, and we are going to make our main pillar. So this one, we create the centroid, or we get these points. And another thing you can do is with adds, you can do a lot of things, but a funny thing you do with adds a lot of the time is you delete geometry with an add. So a little bit counterintuitive, but that is very, very commonly done. So we delete geometry but keep the points, which will delete all those other parts we don't need. And now in this case, we took a circle, which I set here with a random scale. So if I randomize these, it'll give me a different version each frame. And I want to merge a few different kinds of these, but first what I do is I extrude the circle upwards by 0.2. I want to output the front because I want to inset that later. In the next node, I inset that front group, which you can see here. I inset it a little bit, and then I extrude it again. So I extrude that upwards. And then I'm creating a new group, so it saves just this most recent front group. So I only want this top part here. And I'm going to inset it a negative amount to make it bigger. And I'm going to extrude it again by selecting that group. And I'm going to extrude it again. So I extrude, inset, extrude, and inset. And then I'm grouping these all together. And then I'm going to do the same thing here. But this one looks like I'm going to make a thin part for the top of the tower, which will be there. And then this one, it looks like, is the very tall part of the tower, it looks like. So there we go. And then the way I did the match size is I took, obviously, the match size node, and I had the offset. So I took center to max, and then I offset it because I don't want it all the way at the end. I want it with a little bit of extra pull at the top. And then I group those, and then I use those groups again later when I set up the name attribute for our shading in Solaris. So that's one thing. And then for the extrudes, I would just mess with these if I were you. Probably extrude the faces you output. You can do the front and the backs, and then you can also do different things depending on what you want to do with them. So I can blast maybe the front. If I select that. All right, looks like it's grouping everything because it's combining that extrude front with this group, which is why I renamed it. So if I rename it to new, and then I blast extrude front new. Oh, we're going to figure this out. All right, what I'm trying to do is I'm trying to extrude one of these parts and then just blast the top of it. So P I accidentally hit. So what we're going to do is we're going to change the extrusion. I'm going to take this front area. You see I'm extruding that part. I want to create a new group for this top area, and then I want to remove that part. And I could just do that by unchecking that. But to show you the example, I'll do output front, top, and we'll see if I can blast the top. There we go. So I even confused, by extrudes. So mess with them a little bit. The front groups, there's probably a better way actually to organize these, but for the purpose of this, it ended up working out and I achieved what I needed to do. And then you can also maybe stack these or do it different ways. But I did want to showcase a few different ways of setting them up, and there's multiple ways to do it. So it's up to you to decide, and you might even be able to do the modeling side a little bit better than me. So definitely keep trying that. All right, so we copy the towers here to the points, which were, again, just these points here. I'm going to color that as well. And then we'll merge those later. We don't actually need this bottom piece, so I might delete it. And disabling this merge will only keep the leftmost input. And if we need that later, we can bring it back. So to make the wires, which is probably the most fun part of this little setup, we brought in, again, these points. And what I want to do is I want to transform these points up to the top of our tower. And since we know how tall this tower is, I can just use a match size to move them up to that height. And then again, I'll control click to make that visible here. I want to connect these to these. And there's a few different ways to do that, but it looks like the way I chose to do it, and I might even try a different way here, was to create an ID attribute on each of these points, which we can see here is the ID. I create a centroid. I move every point to the centroid, and then I place the centroid at the position here of our tower. So for some reason, I wanted to move the tower lower. So the connection where the wires actually go. If I wanted to move that lower, this match size would let me correctly get wherever this was, so I can make a change to this side of the network, and it automatically follows to this side of the network. And then I did a for each loop where I took each point here and connected, and then I removed points that had unmismatched or IDs that were different. And this probably isn't the easiest way to see if this is your first time looking at a for each loop. So I'll just try a quick explanation. So a for each loop lets us do kind of what you assume. It lets us go through each point. And if I click on this bottom one in a single pass, I can go through each point and I can do a little operation on each point. So here, if I disable this, I'm going through each point here in my input geometry. I'm going to do a null so I can select and view all of these. For each of these points, it's going to say, all right, grab that one point and then take this box, copy it to the point, and then do that for all the other points. What I did in this case was I said for each of those points, which had an incoming ID, and you see if I do a single pass, the ID for this point was 1, this one was 2, you see here, this one was 3, this one was 4, and this one was 0. So I said, all right, for each point, get it in and then merge it with this input stream, which is all of the points. And then I want to delete every point that's not of a matching ID, which probably isn't the best way to do it. So let me see if I can do it a little bit easier now. But what I wanted to do is I want to connect a line between those 2 points. And that's essentially it. So what I could do is take this point, take this target here. Maybe instead of these, because I might not even need this. So let's try to rearrange this a little bit differently. We'll actually do this. So you could do it that way, and I forget why I actually chose to do that, but this will be an easier way to try to do it. So all I'm going to do is take this input point, and I'm going to match it to the centroid of this spot. So now I get this new piece, this target piece. I'm going to get it centroid. I don't need this transform, so I'm going to delete it because that was for the example. I'm going to get it centroid. And I could actually just merge those, which would work fine. Or if there's important data or ID attributes, you'll notice actually here, this centroid point, since it doesn't have an ID attribute, when it merges in, it gives it -1. If for some reason I needed this point here and I need the ID to be copied, I could either use a wrangle to copy the attribute or, whoops, I accidentally just reset my view here. But what I could do is I could either use a wrangle to copy the attribute over or an attribute copy. There's lots of ways to do it. But what I could do is say, all right, take this point here and just match its location. And there we go. Now all we've done is essentially duplicated this point and merged it there, and then we connect it. So this does the exact same things. This, I might have just overcomplicated it, which I definitely did. But if you are interested in seeing how that worked, there's maybe other ways you can do that, but that is a quick setup. So you'll see this again. There's easy ways to do things in Houdini. there's hard, and then there's kind of over complicated ways, which it looks like I actually did there. So, all right, so here again, we add it. So we connect the points, we orient these to create an up and a normal. And we're doing that for good practice. And then for the sweeping later, we do need it, but it looks like we actually recreated it again. So what we're gonna do, we can disable this for now since we don't actually need that. For the resample, we do a create maximum segments. So we wanted 15 segments. We're gonna randomize a attribute for this point. For each point, it looks like. And our attribute seed is ID. So for each of these points, here what we're going to do is we want essentially all of these different ones coming in. We want this ID of 2 maybe to droop a different amount than this ID of 1. So all of these wires have a different shape and a different curve. So that's what I do is I set the seed attribute for a droop value, which is a float, between 0.5 and 3.5. And then I do a wrangle where I subtract by a remap and then I multiply it by a curve. So I will show another way to set this up. And you can see since we have this curve view attribute, we're able to use that. So I'll actually show you how to do that this in VOPs. So I'm going to do a point VOP. And what I want to do is I want to get some kind of displacement, a negative Y position added to the ramp, added to our object, but only in the center. And the way I'll do that here inside this VOP is I will take a bind, which remember from the grass video, we need our curve view, and we need a add, because we want to take our position and add a value to it. And we'll do a constant. So right now, if we just add, and I'm going to middle mouse button and drag, now we're adding a float here to the vector. So I'm going to shake to disconnect, and we'll do a float to vector. So if you see, and I'll connect that again, it added this point value, this 0.5 value to the X, the Y, and the Z. But all we want to do is we want to put this on the Y. So I'm going to create a new vector here with a 0 on the X and the Z. And then I can adjust the Y independently. And what we want to do is we want to put this negative 0.2, but we only want it to be negative where it is a curve view of maybe 0.2 to 0.8. So the way to do that is take a ramp, again, a ramp parameter. We are going to bring that in here, spline ramp, and there's a few ways we could do that. We could displace every point and then lerp or linearly interpolate between those, but we're going to do it in an easy way. And we're just going to multiply our vector, the Y value we're adding, by our ramp. And now that'll put it back to 0. But if we go up and we select this ramp to adjust it, we can now control where on this curve, I'm going to set B-spline, our object is being displaced. And now if we wanted to make this smaller or taller or higher, what we could do is on our constant, well, really what we would do is we would do this middle mouse button and promote this parameter. So we don't need this constant necessarily. And then if I hit U, that parameter is up here. And I could change the name of that by going to here, saying Y displacement. And there we go, Y displacement. And we want something like that. So there it is. And maybe it's closer here or some kind of setup. You can choose how you want to do that. So I will actually put this back here. And we'll leave that one for now. And then the next step, what we want to do is we want to duplicate this line, and then we want to randomize with a noise, and then we want to keep the edges pinned. So we want to do that. We're going to duplicate the line, we're going to create a noise, randomize it. So for each strand, there's a different noise. And then we're going to snap curve u of 0 and curve u of 1 back to its base. So the way we do that is we do a copy and transform. There's a few ways to do this. The way I chose to do this is a better way to say that. A copy and transform will do as what you think it would do. It copies and it transforms the geometry, but we're going to copy it without transforming it. We can do a connectivity, which will give us an integer class attribute based on the connectivity. And we can say this is our wire. So now each point here is going to have our wire, which is an integer attribute we'll later use to create a seed for the noise. So we can do a point vop. And you see here again, we created a noise and a displacement. We created a noise and we displaced the points with that noise. So I'm going to dive inside this point vop and we're going to do the same thing. So I'm going to create a flow noise. We want a 3D noise. So input the position. I'm checking something really quick. Interesting. All right, well, I chose to do it without the seed. It looks like I don't even use the class attribute. All right, so it looks like I don't use this class attribute at all. What I do is I have a prim num, which is similar to a point num, but it's on primitives. So instead of doing that for each of these strands, I will try it with this new attribute I created. So for a wire, since this is already a point attribute, we'll just leave it like that. But what I'm going to do is I'm going to bind it. So I want to get that attribute inside here. And I want to get our wire. This is an integer. And what I want to do is I want to add you see I connected the noise. I want to add this noise to our position. And then I want to randomize it based on this integer. So what I could do is I could just offset by integer. I'll actually do it. I'll promote these and then we'll set that up. So you to go up. Now I have this noise. We'll make this relatively high frequency. And then what I want to do is I'll connect them first and then we'll see what they look like after, and then I'll randomize the connectivity after I already have all of them connected. So I'm going to blend by actually I could just connect here and disable single pass. Well, actually not disable single pass. So right now what's going on is I have my points coming in. All 4 of them are now coming in with the same input position, which means they are all getting the same noise. What I tried to do earlier, and now that I'm thinking about it, was the wrong way to do it. I connected this value, which was unique to each primitive, each wire, and I connected it to the offset, which would offset the noise. But what I rather would do is make this I want to do a float to vector, and I want to take this integer and I want to offset the input. So I'm going to take our noise, and instead of sampling in this space, I'm going to displace, add a little offset displacement to each point, and then I'm going to sample that noise from those points. All right, and that looks like it worked. So what happened again here, if I disable this, these points were coming in and they were being, right now it's just adding that actual integer attribute. So it's adding this value, the 3 the 0 and the 1 and the 2 to the actual y coordinates of these. But what I wanted to do was I wanted to scale those, and then instead of sampling the noise, I wanted to randomize the position in space where that noise is sampled from. So hopefully that makes sense. There's multiple ways to do this. And then the next thing we needed to do was connect the curve U. And we can do that by, it looks like here I actually stored the rest position up here. All right, so what we'll do is we're going to we're going to read back this rest position. And you see if I do v at p equals v at rest, it should snap it back to where it was. But we're going to blend between the current position and the rest position based on a factor, like a float. So I'm going to say v at p equals lerp, so linear interpolate, v at p and v at rest. And we'll do CHF blend. So this is the float, the channel float that we want to blend. Looks like I forgot a parentheses. And now from 0 to 1, I can lerp between the rest position, which is the saved one here, and the distorted position here. But in order to set this for curve U, what I'll do is blend, I'll do say float, mix equals ramp. We'll do remap curve U. And one thing is you can't have spaces in these, so I use underscores. It won't let you do a space. So remap curve U, and I want to do f at curve U. And what I'm doing with the f is I'm declaring it as a float. You might not need these. I do it because I'm used to it as a habit, but you might see other tutorials online not declaring attributes as their type all the time. So I create that value, and that's great. I can do stuff, but nothing's happening yet because we're still mixing with this blend attribute. What now I want to do is inside this function, paste mix, and there we go. Now it's inverted, so what I could do is just flip these points inside my ramp. And then I will change the blend mode, or not the blend mode, the interpolation to a little bit smoother of an interpolation. And there we go. So we got our points. We duplicated them with this copy and transform, or copy and transform without transforming. And you see now we can add more objects if we need, more wires. And then what we did was we displaced them by a random amount, and we set a displacement offset based on our wire. So our integer class, our wire ID that we set here, we added that to the noise, and then we offset that as the noise. We could also do that later. We could do that in the offset or the amplitude or any of those, but that's how I set up. That's how I set it up. All right. Next up is the orient along curve. The reason we do this is again to create those up and normal attributes, the n, which lets us sweep it in the correct way. And it looks like that's actually set up well here. So that is good practice if you're sweeping curves to recreate those, because these attributes are used by the curve, by the sweep node, to create it correctly. Then normal, we'll UV transform. But one more thing is I actually did set up on our sweep. If I set it to round curve, there's no UVs here yet. You have to go to UV attributes and compute UVs, which is why I chose to use the sweep over a different way to create the geometry, is because it can create the UV attributes for you. So I did that, added the normals, and then transformed the UVs to make them, looks like a little bit smaller, and then grouped it and merged it. All right, and now what just happened there is I have this thing set to single pass. So if I disable that, that will let it happen for all of our wires. And you see I can connect these ones. And the reason it's not correctly setting that up is because I forgot to do this p-scale. which is set by class. If I do this, it will not work because there is no class here. It's only our wire. Which should be looks like it's too big. All right, well, it looks like this power function did scale it down. So a lot more of the pieces were smaller. So I just had to change that size. Now if I switch it back, it'll be extra small. So that's one thing to be aware of. The radius will be a multiplication of the P scale, it looks like. So be aware of that. And then we can make this a little bit bigger. If we want those, maybe we actually want more wires. Let's do a lot. Let's do 15. All right. Looking good. And we have our wire. And we merge it in. And then we clean out. Whoops. I just want to put these in here. All right. We want to clean out everything except the tower groups, which again is what we created here to split later for our shading. And then we also remove the extra attributes we did not need. And it looks like that's good to go. So again, we get our tower here, and we did cover this at the start, so we won't go too far in depth here. But we split everything up by its group, and then we add some extra resolution here. You could subdivide this or do anything else you'd want to at this stage, but we essentially just smooth it out to make it a little bit better when we render, create our normals, create our UVs. And then here again, as we mentioned at the start of the lesson, was the subdivision to prep for our polygons going into the VDB from polygons. And the reason we do that is so we don't get these faces vertically along the lines there. So that adds the extra resolution to smooth that out. We convert those back into polygons from the actual volume. And then we create these masks. And we can adjust these, but we could also adjust these later. Whoops. In shading, if it lets me do that. I wanted to change the color there. Ramp from attribute, shade mask. Interesting. I might restart my Houdini because it's not letting me slide. Oh, there it is. But yeah, you can adjust these values as needed. Oh, there we go. If you want to make it darker, you could also do this either here or directly in the shader. And we will actually do this directly in the shader. And then we store our rest attribute for blending noises later. And then we time shift as well to create these variations. And this again was all randomized by our setups everywhere else. I'll color this to make it darker. There's also probably other ways to set these wires up, but this was a way that worked and hopefully wasn't too confusing. So ask questions definitely if you have any, and I encourage you to check out these files and go through them and maybe try to add extra things. And we'll get into wires later once we set up some cool ones for this scene here. Awesome. So that'll be the end of the procedural modeling for the tower. In the next one, we'll continue the modeling and hopefully learn some new cool stuff. So awesome. Thank you, and I'll see you in the next video.